All right, next we have problem 2 here. Ugly, ugly, ugly. So this figure, we got a ball launched with some velocity at some angle, and then it goes up this ramp, which has a certain distance and a certain height, and we have to figure out whether it lands on the ramp or on the plateau. There's no real easy way well, not without a little computation to tell whether it lands on the ramp on the plateau. You can sort of take a guess. So what I want to do first is I'm just going to break the velocity down into components. So 9.5 at 50 degrees. All right, so there we go. V naught equals 9.5 meters per second. The angle is 50 degrees, like that. So let's do velocity naught. That, vector V naught is 9.5 cosine 50 degrees times I hat plus 9.5 sine 50 degrees times j hat. And that equals, let's see, 9.5 times cosine of 50, using my trusty little TI here. So that's 6.11 I hat plus 9.5 times sine of 50 is 7.27 j hat, and this is all in meters per second. Okay, so that's where we're standing here. So let's bring back this, and so with these numbers, now the distance here is 5.60 meters, and or the horizontal distance is 5.60 meters. I mean, to some degree, this sort of comes down to, take a guess. Go with your gut and try it and see if it works out. The way I would look at it is 5.60 meters horizontally here. Our initial velocity horizontally, which is going to be constant, right, because it's not being accelerated downwards, is 6.11. So it's going to take, that's a little bit more than 5.60 meters. So it's going to take not quite a second, just a little bit less than a second for it to get over this far. Okay, so the question really then is, at that point, is it above 3.60 meters? So this, you start off with 7.27 meters per second, the vertical velocity upwards, but that's being accelerated downwards. So you have to sort of guess whether that's going to be enough to push it above here before it gets pulled back downward. My bet is not, because after not quite a second, its velocity is already going to be 0, so it's already going to have peaked out. So I don't buy it. It's going to be after its peak when it gets to this thing here. So I would bet almost anything that it is not going to make the corner there. So I am going to I'm going to bet the farm on this, and I'm just going to take a shot and see if this works. So what I'm going to do is I'm going to figure out an expression for the x distance the ball travels and the y distance the ball travels. So what I'm going to do, or not the x, but the x position of the ball and the y position of the ball. I think you know what I mean. So what I'm going to do is, don't need to edit colors. There we go. Okay, so let's set up a coordinate frame here. There's y, there's x, and we have the ball start at the origin. There's a slope here, and the base here is, I believe they called it D1, and then this here is D2, and then it levels out the ramp. Okay, but there you go. And the ball is launched here. This is our V naught vector here. So what I want to find, this is x and y. I want to find x as a function of time and y as a function of time. So x simply equals, V naught in the x direction times t. And V naught in the x direction, and there's no acceleration in x, right? So it's really just this this here. So 6.11. Well, you know what? I'm gonna do this symbolically, just to keep the symbolic love alive. But here we go. X is V naught xt, and that's V naught cosine theta times t. Okay. Now y is V naught in the y direction times t minus 1/2 gt squared. Usual, projectile motion business there. Okay. So that means y equals, well, y naught, or the initial y velocity, is V naught sine theta. That's times t minus 1/2 gt squared. Okay, good so far. Now there are a couple places to go from here. I'm going to show you the way that I think is most straightforward, but there are different ways to do this. So what I'm going to say is that you know, these are going to cruise along. Let me use blue for the trajectory here. These are going to cruise along, and then at some point they're going to hit here. You know, hit on the thing, and at this point, x and y are going to be on the line of this slope here, right? So at this point, you're going to have y over x is going to be equal to the slope of this slope. So the slope of the ramp, really. The slope is the rise over the run, right? d2 over d1. See this? Okay. d2, d1. This ratio here is the slope of this ramp. And what I'm saying is y and x, when this hits, are going to follow this slope. So that equals y then is, and I'm just going to plug these in. So I'm taking this side here and jerking it over and plugging it in. V naught sine theta times t minus 1/2 gt squared over, over V naught cosine theta times t. And at this point, yep, just gets into nasty algebra. This is nasty. Okay, so d2 over d1 equals, so we can cancel, I mean, for this we can sort of cancel the v naughts a bit, so we can say, well, we can definitely cancel a t everywhere, right? So t goes, and the t squared goes. So then we've got v naught sine theta over v naught cosine theta. So what we really have is tangent theta, okay, minus, and then this is, there's no cure for ugly here. So this is going to be g over 2 v naught t over cosine theta. This is nasty, but we do know all these things. We know d2, we know d1, we know theta, we know v naught, and we know g. So all we need to find is t. So what we can do, oh boy, it's going to be fun. So then, let's see, we do d2 over d1 minus tan theta equals negative gt over 2 v naught cosine theta. Okay, so then t equals, wow, okay, so 2 v naught cos theta over g, and this was negative here, so I'm going to flip everything around here to make this work. So tan theta minus d2 over d1. Holy crap, wow. Okay, so let's see if we can evaluate this. Cosine times tan is going to be sine, right? So this is going to equal 2 v naught sine theta over g minus 2 v naught cosine theta d2 over d1 times over g. Okay, wow, ugly, but you know, you should, if you have all the numbers, you should be able to plug this in, and then what you can say, what they want you to find is, first they want you to find the magnitude of this, you know, of this displacement in y and x, and I'm gonna hold on here for a second because I think people are gonna come in here for 8th period, but I'll finish this up momentarily.